Hello, everybody. I hope this latest message finds you all still doing okay, wherever you are, enjoying what you're doing, adjusting to this new life. Anyway, I'm trying to keep this as real as possible. Okay, learning about galaxies still from the comfort of my own home and the comforts of your own home. All right, so I want to just kind of elaborate on a little bit of something that the textbook covers, and hopefully I can make something a little bit more tangible for you than it would have been otherwise. Okay, so I'm bringing you out to tomorrow's night sky. Doesn't really matter if it's tonight, tomorrow, next couple of days. All right, but these couple of stars, these kinds of stars that you're finding in that are stated in the textbook, they're called variable stars, and the ones in your textbook they're called RR Lyrae, and they're called Cepheid variable stars. Okay, and as you've read, that variable stars basically are stars that change their level of light at different times of the month, different times of the day, et cetera, et cetera. And so I wanted to show for you examples of these two stars and why they might be called that. Okay, so here we are at 1:43 a.m., which is an ungodly hour that, oh, you might find yourselves awake, but definitely not outside doing a whole lot of stargazing, at least. You know, maybe it's not totally out of the realm of possibility, but so I'm trying to keep this real, like show you the perspective of where these stars are now. So that's when these two stars would come out. Okay, um, and so the as far as viewing at a decent hour at like 9 p.m., you would need to go out sort of in the summertime to be able to see these stars at that time. Okay, but so the first one that I want to point out to you is called Delta Cepheus. Delta Cepheus. Okay, so the way stars are named is I mean, obviously the Greeks gave them a large majority of their namesakes, but also the Greek alphabet being alpha, beta, gamma, delta, epsilon, zeta, so on and so forth. Those are letters based on relative brightnesses of stars, and so the alpha star in the constellation Cepheus is going to be Alpha Cepheus. Okay, they might not call it Alpha Cepheus, but it probably have a different name. All right, so we look and see maybe where the brightest star is in the Cepheus constellation. RR is, I believe, that's actually the brightest star. Checking over here again, it says I think it's a 3.18 magnitude. Are there any others with a smaller number of that? Because smaller number means the brighter the object. There's a 3.40, a 2.43. Okay, this might be our alpha star, Alderamin. Okay, 2.43 apparent magnitude. A couple of them, and for the most part, they're minor stars to begin with, in relatively speaking, in the night sky. Okay, so I guess our winner would be Aldemarin for the alpha star in this particular constellation. So the reason that I want to teach that concept, the naming concept, that is we want to bring your focus onto this particular star, and that's Delta Cepheus, okay, or Delta Cephei. All right, so delta being alpha, beta, gamma, delta being the fourth brightest star in the constellation. But that all depends though on a couple of factors. We have this nebula that's visible over here, Cassiopeia A, which is I'm just kind of bringing it out because I know you're very curious about that. 10,000 light years away, extremely dim though, not something you can see really with even the better backyard telescopes. Uh, Being a tenth magnitude is a really, really dim object, so I don't know why they have it kind of popping out quite like that. But so in this night sky, though, let me kind of show you where these would be using the Big Dipper, okay, as a guide. for starters and bring constellation tool. Okay, Ursa Major. All right, we actually use these front two stars of the Big Dipper, and we point to, and bring this one back over. We point to the Polaris star, point to the North Star Polaris. So we point to Polaris. Okay, zooming out some more, pointing to Polaris. I could use the angular, this separation tool to kind of show you, kind of runs right through that particular star. But after we move through Polaris, we actually can, what I say is we continue to the king. We continue to the king. Cepheus is also known as the king in Greek history, the king. And so this is the king constellation. So we, again, the Big Dipper, we go through the Little Dipper, Polaris, and we continue to the king of Cepheus. But we make our way all the way through to Delta Cepheus. Okay, so this is the location of the original Cepheid variable star. It looks like it's actually a double star. Okay, so there's the more you zoom in, you're actually seeing two separate stars. Okay, as we zoom out, though, it definitely turns back into one point of light. So Cepheid variables are named after that star. Okay, and that's because it's a star that varies in brightness over a period of around 100 days or so. Okay, and in that time, what the relationship is that the dimming period back to the brightening period, back to the dimming and back to the brightening. Okay, there's a direct relationship with how long that takes to actually how big the star is, and that's called its absolute magnitude. Okay, so the star here, okay, it's showing you its apparent magnitude. It doesn't list here specifically its absolute magnitude. All right, but basically it's a big star absolute magnitude wise. I can bring you up other charts to show you what that would be, but I'll spare you at this time. All right, so it's a big star, and because of that, because it's a relatively big star, it has a long period of lightning variability. All right. On the other hand, other kinds of variable stars are called, all right, RR Lyrae, Lyraes, RR Lyraes, and RR Lyraes are so named because now I'm bringing up to you not just the constellation. Okay, it's in the boundary zone of the constellation Lyra, but so these stars that are named for their constellations that they're in. Here's, I'm pointing to Kappa Lyrae. All right, they're not necessarily in the constellation itself. They could be well outside of the constellation, but as long as they're still in the boundary. And RR Lyrae is a much smaller absolute magnitude variable star. So the reason that we know that is because it actually has its brightening variability on a period of a matter of a couple of days. Okay, whereas Delta Cepheus, okay, and this is, I'm trying to zoom in to show you exactly where that is, right over here. And it's funny when I transfer this over to YouTube, it's the pointer seems a little bit off. So it's just an observation that I made. So this absolute magnitude is much smaller, and that's the exact relationship that we are learning. That the faster the variability in the star brightness, the smaller the absolute magnitude. That's the relationship. Okay, and again, the opposite is true. The longer the time period for the variability, the larger the absolute magnitude is. Okay, and so that's just basically an intro to variable stars mentioned in your textbook. I'm not sure if you're going to view the video after this tutorial or before this tutorial, but it's a fascinating story of how variable stars were discovered and their importance to us. And actually, I didn't even mention that at all. And that is, they're important because they are the guideposts. They are the primary landmarks in the sky for teaching us about the distance of anything. If you have a few standards like RR Lyraes and delta Cepheids, okay, those are standards of known distances in space. Right? Known distances in spaces are really important for getting your baselines, no matter what direction you're looking in. Even though the study of distances in space is kind of in its infancy, all right, only in the last 100 years or so. So that there's still a lot of variability in terms of what scientists claim is the distance to an object might be. So like this brightest star here in Vega, Alpha Lyrae is also known as Vega. Okay, it's showing up as a 0.00 apparent magnitude star. Okay, at 25 light years away. So the standard of learning about variable stars really teaches us about distances of a lot of different other objects in space, including, okay, which one is, if we look at a point of light in the sky, is that a star, or is that a nearby star, a star just a dozen light years away or so, or is it a galaxy a couple 100 million light years away? All right, and that's the importance of what variable stars share for us. Okay. All right, so hopefully you found this useful. Hopefully you found this relevant, and hopefully it helps you understand a little bit more about that textbook passage. All right, stay well, people. Talk to you later. Signing out.